Okay, hi there Year 13s. In this video we're going to look at calculating exact compound angles. That basically means working it out without using your calculator. And so here we've got two values of different angles of tan, and the question is asking us to work out what tan of A minus B is, even when we don't know what A and B are. So what I'm going to do is look in my formula for one that has tan of A minus B. So here it is here, and I'll just quickly copy that and bring it over. So we'll put it in, where are we up to here? So I'll just put it on the side here so I've got it as reference for me. So I'll bring that over and reduce it in size a bit. That's better. Okay, and so what I'm going to do is write each of these bits, substituting them for these numbers here and here. So I'm going to write tan A minus B equals, and instead of tan A I'm going to write 1.2, and because we've got plus and minus here, plus and minus here, I'm going to write minus here. So in other words, if this is plus, then this is plus. But if this is minus, then this is minus, and it works the other way around for the bottom. So if this is plus, the bottom is minus, and if this is minus, then the bottom is plus, if you get the idea. Okay, so on the top we've got 1.2 minus 0.75, and on the bottom we've got 1, and it will be plus 1.2 times 0.75, and so now we can put that, well, we could work it out manually if we want to, but I think we'll put it into our calculator. So 1.2 minus 0.75 divided by 1 minus 1.2 times 0.75, and that gives us 4.5. So 4.5, and that's our final answer. Okay, so over in our next example, we've got a similar thing again with two different angles with acute values. So they're asking us to find the value of sine alpha plus beta. So once again I'm going to go to my formula and find a formula for sine of alpha plus beta, and we have one here, so I'll copy that over as well, so we've got that ready access. Okay, so let's just paste that in, make it a bit smaller, and we'll bring it up over, whoops, we'll bring it up here, doesn't want to move, here we go. Okay, so I'll write out sine alpha plus beta, and then I'll substitute in these values instead of the ones that we have here. So we'll have equals 1 over 3 times 1 over 2 plus, actually I'll have to backtrack because we've got to have cos in here. So because we have to have cos in there, what I'm going to do is draw out a triangle first for each of these, and so for sine of alpha, that's going to be hypotenuse of 3 and opposite of 1, and so this side here is going to be the square root of 3 squared plus 1 squared, so that'll be root 10. And for our, that's right angle triangle, for our beta angle we've got 2 and 1, and so this is going to be the square root of 5, 2 squared, oh, that should be minus, so that will be minus as well, so that will be root 8, and that will be root 3. Okay, root 8 of course is 2 root 2. Okay, so now because we've got this cos part in here, we'll have to work out cos for each of these. So cos alpha is going to be adjacent over hypotenuse, so 2 root 2 over 3, and so that's equal to, and cos of beta is going to be adjacent, which is 3, over hypotenuse, which is 2. So now that we've got cos alpha and beta, we can use that formula, and so we can write out that sine alpha plus beta is going to be equal to 1 over 3 times root 3 over 2 plus 2 root 2 over 3 times 1 over 2. And so now we can work to simplify these fractions, and so that will be root 3 over 6 plus 2 root 2 over 6, and we can combine that into one fraction, so root 3 plus 2 root 2 all over 6, and that's already rationalised, so we don't need to do anything further. Okay, so that's how we can use the compound angle formula to find exact angles, and you can practice some of those in 6.04.